Good day, grade 10 learners. Welcome to today's physical sciences lesson brought to you by the Gauteng Department of Education. Today, we are going to talk about concentration, which is a topic that is assessed in paper 2. My name is Bongani Mabuya, and I will be with you throughout this lesson. So this is what we are going to talk about today, concentration. That is the topic of the day, concentration. So what is it that I want you to know at the end of the lesson? You must be in a position to define concentration, express the formula of concentration, and calculate concentration. This is what we are doing today. We define concentration, we express the formula of concentration, and we calculate. This is what we are doing. Very simple. So we are talking about one thing, one concept, concentration. That is the topic of the day, concentration. So we need to refer to the exam guideline in conjunction with the CAPS document. So what is it that you know? It is to balance chemical equations. It is to write chemical equations and formulas and to calculate the number of moles. This is going to be handy in this topic. So it is important to remind yourself, be in cognizance of these three things: writing chemical formulas, balancing the equation, and also calculating number of moles. So I am going to give you 5 minutes to respond to this baseline assessment. In 5 minutes, right? For these two calculations, we are going to need a calculator. So you need to make sure that you have a calculator in your possession. Let's look at this baseline assessment. We are assessing the skills that you are going to need when we deal with concentration, more especially when we calculate for concentration. And the first one, it is you need to be in a position as a grade 10 learner to convert. So it is very important to know how to convert. Number two, you should be in a position to calculate number of moles. This is your prior knowledge. This is what you already know. So these two questions, they are assessing the skills that we are going to need to make sure that we tackle this concept concentration. We must be in a position to know how to convert, and also we should be in a position to calculate for the number of moles. And I always say this, when it comes to writing formulas, make sure that you copy them from the formula sheet the way they appear. So it is very important to write down the formula the way it appears. And then what do? You substitute. This is how we win. You write down the formula, and then what do? You substitute. 70% of mark allocation comes from that. Writing down the correct formula and substituting correctly. So this is what we will be assessing as well. Let's look at the first question. Convert 500 centimeter cube volume of hydrochloric acid solution to decimeter cube. So we must convert centimeter cube to decimeter cube. We are moving from a smaller unit to a bigger unit. When we move from a smaller unit to a bigger unit, we divide. That is very important. When you move from small to big, we divide. So that is what we need to do. We must convert this smaller unit to a bigger unit. Centimeter cubes, they are smaller than decimeter cube. So we are going to divide this by 1,000. So you're going to have 500 divided by 1,000. Then your answer will be 0.5 decimeter cube. So this is very important. This is very important. So it's a skill that we are going to use on a continuous basis. Let's look at the second question. Calculate the number of moles. This is what the question wants. This is what the question wants, the number of moles. Calculate the number of moles. What is it that we are given? We are given the sample mass, which is 100 grams, small m. And we can get the molar mass of silver nitrate by using the periodic table. I always say this, when we deal with chemistry, a periodic table must be your friend. Periodic table is our best weapon to tackle any chemistry issue. So it is very important to make sure that we are familiar with the periodic table. So silver nitrate, it is composed by Ag, which is silver. You go to your periodic table and you must extract the mass of silver. I think it is 108 grams per mole. Plus the mass of nitrogen from the periodic table. Nitrogen is number 7, meaning that the molar mass of it is going to be 14. Plus the molar mass of oxygen is 16. How many oxygens do we have? How many do we have? We have 3. So we multiply this by 3. Then you go to your calculator. 108 plus 14 plus 16 times 3. And what's going to be your molar mass? I think it's going to be 170 grams per mole. So this is what you have. You have the small mass, you have the big mass. So this informs the type or the kind of number of moles equation that we are going to use. That says number of moles is equals to sample mass divided by molar mass. So what is your small m? It's 100 grams divided by molar mass, which is 170 gram per mole. So gram and gram, they cancel each other. So what's going to be our answer? We are going to say 100 divided by 170. And then you're going to get 0.59 mole. So this is what you were supposed to do. You get 0.5 mole. So maybe for this question is 3 marks. It's 1 mark of the formula. But you only get this 1 mark provided that you have substituted. So you don't just write the formula and expect to get a mark. Write the formula and substitute. You get 1 mark for the formula. Then the second mark will come from the correct substitution. Then 1 mark for the answer. So you can see that the final answer only carries 1 mark. So it is very important, grade 10 learners, to make sure that you put yourself in a position that will enable you to score more marks. So we write down the formula, we substitute correctly. So I did say that the topic of the day is concentration. That is the first thing that you ask yourself. What is concentration? That is the first thing that must come to your mind. Concentration. This big elephant that we are talking about today, what is it? So by the end of the lesson, we should be in a position to define and discuss what? Concentration. What is concentration? That's what we are talking about today. Concentration. So what is concentration? But before we can come to concentration, we need to understand this term mole. A mole is a SI unit for the amount of substance. That is what the mole is. So what is concentration then? Concentration, it is the number of moles. I am highlighting this so that you see. It is the number of moles per cubic decimeter cube of solution. That is what concentration is. It is the number of moles of solute per cubic decimeter of solution. I love what I'm saying. I'm enjoying what I'm saying because we need to understand this statement. It is telling us what is the number of moles per cubic decimeter of solution. What is that? Concentration. So when we define concentration, it means concentration is number of moles of solute per means divide. So it's number of moles of solute divided by what? Cubic decimeter of solution, which is what? The volume. So when we talk about concentration, we are talking about number of moles of solute divided by what? The volume. That is what a concentration is. Number of moles of solute divided by what? By the volume. So this definition, it gives us the expression of the formula of concentration. This is powerful. It leads to the formula. So the definition, it tells us that concentration is what? The number of moles of solute divided by what? By volume. So let's look at the expression of concentration. This is the formula. Concentration is equals to number of moles divided by what? By the volume. We get this from what? From our definition. The definition, it tells us what is concentration. It's number of moles of solute divided by what? By the volume. In decimeter cube. So our volume should be in decimeter cube. And we get this information from the definition itself. So it is very important to sing the definitions because it's 2 marks or nothing. So when you are confronted with a definition, emphasize that definition to yourself. Make it your national anthem. What is concentration? It's the number of moles of solute per cubic decimeter of solution. What does that mean? It means that concentration, its number of moles per means divide. So it's number of moles divided by what? By volume. And this volume must be in what? In cubic decimeter. I hope that we are winning. Let's move on. So this tells us about the units for concentration. So the units for concentration, it's mole per decimeter cube. I love what I'm saying. It's mole. This dot means divide by decimeter cube. And where do we get this from? From the equation itself. Because concentration, it's moles divided by what? By volume. So these are the SI units for the concentration. And there's a typical error that learners commit. You tend to omit this negative. It is very important that when you express the units, express them correctly. So the units for concentration, it's mole per decimeter to the power of -3. So please do not omit this negative, because these are the units, these are the correct units for concentration. So that is what we are talking about today. That's all. This is the lesson of the day. This is the lesson of the day. If you grasp this, you are gone. When we talk about concentration, we are talking about what? The number of moles of solid per cubic decimeter of a solution. This is what the concentration is. Number of moles of solid divided by volume. Volume in what? In decimeter cube. And we are saying that this definition, it expresses the formula, which is concentration is equals to number of moles divided by what? Volume. And what are our SI units for concentration? Mole per decimeter cube. Mole per decimeter cube. So it is very fundamental that we are in a position of defining concentration and know how to express the formula of concentration and then calculate concentration, which is what we are going to do now. So it is important for us to understand this concentration. Concentration, number of moles divided by volume in what? In decimeter cube. So if we find a volume that is not in decimeter cube, it is our duty. It is our duty as grade 10 learners to make sure that we do what? We convert the volume to what? To decimeter cube. Because the definition says per cubic decimeter. So our volume must be in decimeter cube. This is what we are saying. That let us master to do the right things. Let's do that. So it is important to know how to write the formula. Concentration is equals to number of moles divided by what? By volume in decimeter cube. Our volume should be in decimeter cube. Let's move on. Let's move on. So I always say this, let us capacitate ourselves with a periodic table. It's very important. Knowing a periodic table, it will take you far, more especially in chemistry, because it's our best weapon. This is what we use. So it is your duty and responsibility as a grade 10 learner to familiarize yourself with the what? With a periodic table. This is our weapon. This is what we are working with, a periodic table. When we talk about nitrogen, you see, it's number 7 in the periodic table. The symbol for nitrogen is N. And then the molar mass is the number below, which is 14. So make sure that you understand the periodic table. It is our best weapon. Let's move on. So when we talk about concentration, it must involve these 3 concepts: concentration, number of moles, and volume. They form this triangle relationship. Concentration in mole per decimeter cube. These are the units for concentration. Moles, the units, it's mole, and volume in decimeter cube. So this is our concentration. Concentration is equals to number of moles divided by volume. You can be required to calculate for volume, provided that you are given the concentration and number of moles. You can calculate number of moles if you can find concentration and volume. So that is why we say that they form a triangle relationship. Let's move on. Let's look at this now. Now we calculate concentration. Let's look at the question. It says calculate the concentration. That is what the question wants. It wants us to determine the value of concentration in mole per decimeter cube of phosphoric acid solution that contains 0.1 mole. So you see, this is what we are given. We are given the number of moles of phosphoric acid. And also we are given the volume, which is 2 decimeter cube of water. So that's the first thing that you do. You write down what you are given. This is what we call it data. Write down your data. You are given the volume in decimeter cube, meaning that there is no need for us to struggle. Already it is in the correct units. We are given the number of moles, so we can get concentration. So now these three things, they inform our equation. Concentration is equal to number of moles divided by what? By volume. So you express the formula. Concentration is equal to number of moles of phosphoric acid divided by volume. Now, you get 1 mark for this, provided that you are going to substitute. So now, you substitute. What are your number of moles? 0.1. Divided by what? Volume, which is 2. And what is your concentration? It's 0.05 mole per decimeter cube. So this is how we determine concentration. Let's move on. Let's move on. So here's another question. I think this one carries 5 marks. It's a 5-mark question in your exam. Calculate the concentration. That's what the question wants. At the end, our answer, we are determining concept. This is what we are doing. We are determining concentration. So calculate concentration if we have 5.8 grams of this table salt, sodium chloride, which is dissolved in 2 decimeter cube of water. So now, for us to use the formula of concentration, remember we must have number of moles divided by volume. And when we look at this, we have molar mass. We can find molar mass. We can also find sample mass. And because we have this given mass, which is a sample mass, we can have molar mass and calculate for the number of moles. Then once we have the number of moles, then we can use the concentration formula that says concentration is equals to number of moles divided by volume. So this is what we are saying. Because we have the sample mass, small m, which is 5.8 grams, we can get the molar mass of sodium chloride. You go to your periodic table. Sodium is number 11 in your periodic table, and the molar mass of it is 23. Plus chlorine, the molar mass of it is 35.5. So what is our molar mass? It is 58.5 gram per mole. So we have the sample mass, we have the molar mass. We can calculate the number of moles, which is our first step. So we use the formula number of moles is equal to sample mass divided by what? By molar mass. And then what do? We substitute, because it is very important. We win with substitution. Write the formula, substitute. So we substitute. What is our sample mass? 5.8 grams divided by our molar mass, which is 58.5. So what are our number of moles? It's 0.1. So now we have the number of moles and we have the volume. We have the number of moles, 0.1 mole. We have the volume, which is 2 decimeter cube. So we can find concentration. We can get it. We can get concentration by using the formula. Concentration is equal to number of moles divided by what? By the volume. And you substitute 0.1 divided by 2. And what's going to be our concentration? 0.05 mole per decimeter cube. So I did say that a question like this carries 5 marks. So 1 mark for this formula, 1 mark for substitution. 1 mark for the concentration formula, 1 mark for substitution, 1 mark for the final answer. And we are saying that write the formula. Copying a formula from the formula sheet, it is not a sin. It's not a sin. You must copy that formula sheet and substitute. Because this is how we win. Copy the formula, substitute. This is what I always emphasize. Make sure that the substitution is correct. So you can see it's 5 marks. Formula, substitution, and 1 mark is credited for the answer. So let's move on. Here is another situation. Calculate the number of moles. You see, now we are playing with the formula. Calculate the number of moles of hydrochloric acid, provided that we are given the volume, which is 250 centimeter cube, and the concentration of the solution is 0.3. So we have the volume, which is 250 centimeter cube. Now it poses a challenge. Let's say this is a 3-mark question. It poses a challenge because our volume must be in decimeter cube. And as grade 10 learners, we need to be happy when we encounter challenges. Challenges should make us happy because we are problem solvers. So we have this problem, 250 centimeter cube, and something must click to your mind that no, we need to convert this volume to what? To decimeter cube. So we divide by what? By 1000, and your volume will be 0.25 decimeter cube. You'll pardon my handwriting. And then we also have the value for concentration. Now, the question requires us to calculate for the number of moles. You write the formula as original as it is. Okay? So you write it as original as it is. Concentration is equal to number of moles divided by what? By the volume. Okay? Then substitute. What is our concentration? 0.3. What are our number of moles? We don't know. And what is our volume? In decimeter cube, it's 0.25. So write the formula as original as it is and substitute from that original formula. Then after, that's when you can show us your mathematical skills and show off. It's fine. But make sure that when you write the formula, you write it as original as it is, as it appears from the formula sheet. 2, substitute correctly from that formula sheet. And then you work out, and then you're going to get your answer. How will you work out? You're going to transpose divided by 0.25. And you're going to have 0.3 times 0.25 is equals to number of moles. Then your number of moles are going to be 0.075. I hope that you're winning. Because I want you to be comfortable with concentration. Let us be comfortable with concentration. Let's move on. So I'm going to give you 3 minutes to respond to this question, just to assess, are we moving on the right pace, all of us? Are we in the same page? So I am going to give you 3 minutes to respond to this question. Now, I am interested in your response. But before we can get to that, make it a point that you send us your response on our WhatsApp platform, which is 064 748 8913. Make it a point that we engage. I'm within your reach. Let us talk about this. So we were confronted with a challenge, and here is our challenge. It says calculate the concentration. That is what the question wants. Calculate the concentration. Calculate the concentration of sulfuric acid solution that contains 2 moles in 600 centimeter cube of water. So that is what you do. You write down your data. The question requires us to calculate for concentration. What is it that we have? We have the number of moles, which is 2 mole, and also we have the volume, which is 600 centimeter cube. And you can see that our volume is in centimeter cube. So the prerogative, it is with us to make sure that we convert from centimeter cube to decimeter cube. So what do we do, learners? We divide by 1000. Therefore, our volume will be 0.6 decimeter cube. Then, now we have the volume in the correct unit. We have the number of moles. We can calculate for concentration. We can say concentration is equals to number of moles divided by volume. What is our number of moles? It's 2. It's 2. Our number of moles, and our volume is 0.6. So you're going to say you're going to say 2 divided by 0.6, and then your answer would be 3.33 mole per decimeter cube. And you can see how we write the units to the power of -3. Let's move on. So this one, it's a 5 marks question, and I also want you to do it. Yes, I want you to do it, and then after we will look at your response and make it a point that you engage with us on our WhatsApp platform. Again, it is 064 748 8913. It's very important that we engage with knowledge. At the end of the day, this is for you. This is for you. So let us strengthen our relationship to make sure that we tackle content. So for 5 marks, let us try to solve this challenge. It's our challenge, so we get excited when we get challenges. In 5 minutes. Now, let us look at your response. It's a 5-mark question. I hope that you are not intimidated by that. The question wants us to calculate for concentration. It's very important to comprehend the question. So we must read to understand. The question wants us to calculate for concentration. This is what we want, concentration. But we are given the sample mass of solution if 118 grams of sodium chloride dissolves in 300 centimeter cube. So this is what we have. So we have the sample mass of sodium chloride. And once we have the sample mass of sodium chloride, we can get the molar mass of sodium chloride. And when we have both of them, we can calculate for the number of moles. So let's do that. So we have the sample mass, which is 118 grams. We need to find the molar mass of sodium chloride. Sodium, the molar mass of it is 23 grams per mole, plus the molar mass of chlorine is 35.5 grams per mole. So I think your answer will be 58 grams per mole. 58.5 grams per mole. So this is our molar mass. So we do have the sample mass and we do have what we call what? The molar mass. So we can find the number of moles of our table salt, NaCl, by using this formula. Number of moles is equal to sample mass divided by molar mass. And what is our sample mass? Our sample mass is 118 divided by our molar mass, which is 58.5. And our number of moles will be 2 mole or something relative to that. We can prove it. 118 divided by 58.5, and our answer will be 2. It's 2.01. Now that we have the number of moles and we have the volume, because our volume is 300 centimeter cube, we need to convert our volume to decimeter cube. So we divide by 1000 and we are going to get 0.3 decimeter cube. Then, because we have the number of moles and we have the volume, now it's easier for us to determine concentration. So we are going to say concentration is equal to number of moles divided by volume. Our number of moles is 2, our volume is 0.3. And what's going to be your answer? 2 divided by 0.3, we are going to get 6.67 mole per decimeter cube. So this is what we get. So this was a 5 marks question. And we are saying that we win with writing the correct formula. We win by substituting. So for writing this formula, 1 mark. For substituting, 1 mark. So you have 2 marks. For writing the formula, you have the 3rd mark. Correct substitution, it's a mark. And your answer, it's a mark. So this is how you will be marked as well. Let's move on. So I'm going to give you 5 minutes as well to respond to this question. It's a bit complex, but I trust you. So see you after 5 minutes. Now, let us try to respond to these answer. The first thing that we need to do is to understand the question. That is very important. Let us fight to understand the question. 30 centimeter cube of calcium carbonate. So this volume is attributed to calcium carbonate. Is added with sulfuric acid to produce calcium sulfate, water, and carbon dioxide. The volume of carbon dioxide at STP, and at STP, we know that the value is constant, is 22,4, is 40 centimeter cube. So the question says, determine the concentration of calcium carbonate. The first thing that we need to do is to express this equation. It's very important. So we have what we call calcium carbonate. It reacts with sulfuric acid. And we are told that it's going to produce calcium sulfate, and it is going to produce water, and it is going to produce carbon dioxide. So this is what we have. This is our reaction. Now for calcium carbonate, we have the volume. And our volume is in centimeter cube. And our volume must always be in decimeter cube. According to our definition, we define concentration as number of moles of solute per cubic decimeter of a solution. So we have 30 centimeter cube. We must convert it to decimeter cube. So you divide by 1000, and I think you're going to get 0.03 decimeter cube. So this one is for calcium carbonate. And then the volume of carbon dioxide. Now, at STP, the volume is 40 centimeter cube. We must convert this volume to decimeter cube. So we divide by 1000 and we get 0.04 decimeter cube. So it's very important to make sure that we make our lives easier. But here now, for carbon dioxide, we are also told that the volume of carbon dioxide at STP. So meaning that we do know the molar volume at STP, which is 22,4. So we can calculate the number of moles of carbon dioxide. So that is the first step. Calculate the number of moles of carbon dioxide. So we're going to say number of moles of carbon dioxide is equals to volume divided by molar volume at STP. So we use this formula if we have volume and if we have molar volume. So what is our volume? Our volume is 0.04 for carbon dioxide divided by molar volume, which is 22,4 decimeter cube. So what's going to be your answer? 0.04, 22,4. And we are going to get 0.0018 mole. So this is what we'll have. Now that we have the number of moles of carbon dioxide, we go to step 2. So this is step 1. So now we go to step 2, which is use molar ratio. So when we talk about molar ratio, we are saying that, let's look at this equation. It's balanced. Yes, I can see it's balanced. So it means that the number in front represents the number of moles. We have 1 mole of calcium carbonate. We have 1 mole of sulfuric acid. We have 1 mole of calcium sulfate, 1 mole of water, 1 mole of carbon dioxide. That's what it means. So when we say use molar ratio, we are saying that the number in front of that balanced chemical equation represents the number of moles. And the question wants us to calculate for concentration of calcium carbonate. So we use the molar ratio for number of moles of carbon dioxide. against the number of moles of calcium carbonate. And the number in front for carbon dioxide, it is 1. The number in front of calcium carbonate is 1. Then the number of moles of carbon dioxide that we calculated, it's 0.0018. And the number of moles of calcium carbonate, we don't know, so we make that x. We cross multiply. So 1 times x is x, and meaning that our number of moles is going to be 0.018 mole. So the number of moles of calcium carbonate, it's 0.0018 mole. So this is what we have. So now we have the number of moles of calcium carbonate, and we also have the volume of calcium carbonate, which is 30 centimeter cube. We've converted it to decimeter cube. So our next step, which is step 3, we write the formula for concentration. Concentration is equals to number of moles divided by volume. Concentration of calcium carbonate is equals to the number of moles of calcium carbonate, 0.0018, divided by volume, which is 0.03. So what will be your answer? It's going to be 0.06 mole per decimeter cube. So this is what you are supposed to do. So you apply those 3 fundamental steps, and then you will win. You will win. You will win. So we are saying that the power, when you do calculations, make sure that you copy the formula as it appears, substitute. If you can worry about having a correct substitution, you have won physical sciences. And let this conversation not end. Let us continue to engage with physical sciences. Let us continue to seeing the definitions. Science is something that we should talk about all the time. We are scientists. So it's very important to make sure that we engage with knowledge, we solve problems. See you next time. I thank you. I thank you. I thank you.